What's up guys, Eddie67716 here, and welcome to my third redstone tutorial. Now in this tutorial we are going to look at piston powering. Now piston powering is a little bit more complex than powering most other components, because pistons aren't exactly a solid block, they're transparent. I don't know how that works, but I think they're just like lamps, but they're different, but they're very different. Anyway, this is going to show you the basics on powering a piston. So, this setup I have here is a redstone line going by a block with a piston on top of it. But this is not going to work because the redstone is not facing the block, so nothing happens. However, if you replace that with a target block, it will work. See, target blocks allow redstone to turn direction and always face them, which thing means this block will be powered, which will power the piston. So that works. This one won't work because the redstone is not facing the piston. However, this will work, but only kinda, because it will destroy the redstone on top of the piston. So it kinda doesn't work. Now this example is gonna work because this block is gonna be powered, so it will power the piston. Now this next section is how to power a row of pistons, but this one will not work. You see, the line of the redstone is facing into the piston, so it doesn't work. This won't work either because the blocks are not powered. This, on the other hand, will work because the redstone signal faces a target block, so you can see that that works. This one is for powering two rows of pistons on top of each other. Now this one will only power the bottom row, because it goes along here powering all these blocks, because redstone always powers the block below it if it's a solid block, but it's not powering the piston since nothing's facing into it. Now this example, it works because this block is powered and it powers these pistons, but I don't actually understand why this works, but it does. Somehow this either powers this, or maybe it's similar to my lamp thing where it powers all the completely connecting blocks horizontally and vertically, but it works. This example will not work because slabs can't power a block, so the redstone cannot power the slabs, so they don't power the pistons. This little thing up here will work, on the other hand, so if you flick that, it powers this piston, and I still don't understand how it powers the piston below it, but it works. Now, to craft a target block, what you need is a bale of hay, and it needs redstone surrounding every single side of it, and that's how you use a target block. Now, target blocks always allow the redstone signal to face it, no matter what angle it's coming from. This is why, if you power it, it can power a piston next to it, which is actually only the second use that target blocks have. The other use is they emit a signal strength based on how close the arrow is to the target, but I'll explain some more on that later. Now, this is a very complex part of piston powering, which makes a lot of redstone users give up, and they decide we can't do it, it's too hard. You see, pistons have a strange thing where they will be powered by a block on the side, but not directly. So if I turn this lever on, and I power this block, and I turn this lever off, or on or off again, it's being powered. And if I turn this off, it's still powered. However, if I update this lever back to the off position, it will happen. This is known as block update detection powering, or bud powering pistons. It can be a bit complex for first time, but these are the two main scenarios you need to avoid. A block on the side that is powered, or this one, which is a block above the piston being powered. So if I flick that on, I flick this on, I flick that off, and then I flick that off, you can see it's bud powered. Only once this is off truly will it truly turn off. So that's all you're going to need to know about pistons. In the next section, I'm going to show you about redstone torches. Alright, now for the next section on redstone torches. Now this is going to be very complex, so I have to take you through it slowly. Now redstone torches can be used as a power source, as shown here is powering that signal of redstone. But Redstone torches are one of the most powerful of redstone components because it allows for manipulation of signals. You see, if this block is powered, this torch is going to turn off. And that allows for some very complex circuitry options, and it creates an inverter, also known as a NOT gate. And there are many uses you can use a NOT gate for. You can chain them together, and you can is rising circuits or elevators of redstone torches. But here is a simple use. If you want to create a circuit that when it's on, it powers a circuit, and when it's off, it powers another circuit, this is what you need to build. It's called a rising edge, falling edge circuit, but if it's on, it powers this line. If it's off, it powers that line, and vice versa, creating a pulse, so you can alternate power two different circuits. Now, this part is going to be really complicated, but all you really need to know is that NOT gates can be chained together to make other logic gates. An AND gate, like this one, the lamp will only be on if both inputs are on, so that uses two NOT gates, and only if both these gates are off will that torch be on. So it allows for very complex circuitry like that. No other combination will allow that. Or this device known as an OR gate. It will be on if any of the inputs are on. So as long as this torch is off, there will be an output. So when this torch is off, it makes this torch on, and there's an output. And it's the same with this lever and both. The next example we have here is a bit more complex, the exclusive OR gate. It is only on if one of the inputs are on. So you see it's off, but if this signal is on, there's an output. And if this signal is on, there's an output, but both mean there's not an output. Now it uses some complex torch chaining stuff, which is a little bit complex to explain, but like it will only be on. Like, this will only be on if one of the torches are on, and there's no scenario which makes both those torches off. But you can also make some other types by adding a NOT gate to a XOR gate, making a XOR gate, or removing the last NOT gate from the gates, allows you to invert the output. So an AND gate is the exact opposite of an AND gate. It's only on if both inputs are not on. So it's on until both are on, and same with this OR gate. This will only be on if both inputs are off or one is on. Or if both inputs are off, it's on. And the XNOR gate, which is only on if both inputs are the same. So if both are off, it's on. If both are on, it's on. And if one of them is different to the other, it's off. So that can be used for comparing circuits. Now, redstone torches have a problem where they can self-power and then burn out. So if I place this here, you can see that the torch turns on and off, and then it burns out. So it creates a simple timer, but it's not controllable because in most ways, because it just turns off. But anyway, that's all I need to show you in my testing world. Now I'm going to transfer to my redstone machine tutorial world where I can show you a few examples where this will be useful. Alright, here I've got a very simple corridor, and if you walk over it, you fall into this bath of lava. So, how did that happen, may I ask? Well, it's simple. I built this redstone circuit that controls a simple trapdoor, so if something's on here, it opens that piston and retracts it out of the way, and then these two pistons pull it back, revealing a bath to a deathing lava. So how does this work? So you see, I have this NOT gate here, which will unpower this piston. Then after a delay, it will unpower this piston. And then if you get released off, like this gets powered on, but it doesn't power the piston because it's only powered by this block here, and this will power before that gets powered. So if you watch here, it's pulled back, but that piston's not going to be powered until it touches this block. And thus, it creates a trapdoor. So now, to build this device, what you're going to need to do is get a block and place a piston here, and then 2 blocks away, place some pistons here. Like this is what will look like when compacted, and this is what will look like when it's on. So what you're gonna need to do is put a redstone torch here, which will create a simple NOT gate. Then bring a redstone signal down here, so it will power that piston. Then you need to create a delay right here, and then you need to power this, which will power this block, and then it will power here, and you don't need a torch there. So set this to 2 ticks. This is important, otherwise it won't retract that. So when you sit here, it pulls it away, and then when it goes, it retracts it back. So you can build a simple... I'm trapped. I'm trapped! I'm just destroying the redstone. So that was meant to stay. Oh well. Well, but you get the idea. It's a simple trapdoor, and it can fall into a pit of lava. And that ought to do the trick. Alright, say you have this little cliffside, and you want to build a door, a secret door that allows you to go through the other side, but not to show any indicator that there actually is a door here. Now there's a special door you can use to get through this. It's known as a Jeb door. Now what that does is it has a column of stone which will get pulled back to here, and then it and the piston that pulled it back will be pulled back here. So what you need to do is place 4 pistons like so, then place 2 pistons, which are the ones that will retract the blocks. Then place 2 blocks of your choice, depending on what the wall is made up, like this. Now what I'm going to need is something to power the door. So I'm going to put a lever here on the other side with a NOT gate. And I'll just turn the lever on to make it easy. Then I'm going to need to take the blocks and go across these 2 pistons and that piston. So this is going to be how you power the pistons. So you need to take a redstone signal here. Now this is very important, because this redstone is going to be what powers these 2 pistons, which will extend their blocks to block off the doorway and retract it when closing. Then you gotta place a repeater here on 2 ticks, and then 2 pieces of redstone here and here. So these redstone are going to power these 4 pistons. So when I turn this off, it will turn this signal on. It will turn this piece of redstone on, but it won't power these pistons here due to the repeater, because repeaters do not power the blocks below them, but redstone does. Then this redstone will turn these 4 pistons behind here on, and then this piece will turn these 2 on, which will retract the block, and it will make as if there was no door here. So, where's the door? Where's the door? So, you can like have a secret block where you place a lever, and then we want to come through the door. You can open it. Oh, I see what I've done. It's some sort of bud powering thing, because if this goes off, the door works fine. But for some reason, turning it off here, all the blocks retract at the same time. So something about these pistons are being bud powered, but I think I know how to fix this. Alright, I've managed to fix the issue. This block here was bud powering these 2 pistons, so they will only retract when that went off, and I don't know quite how that works. But now the whole thing should work fine. So if I close the lever, it's gone. And you remove it, it's a distinct wall. But if you put it back and flick it on, you can go through. And there you have a Jeb door. Now, you can also do this in a 2x2 variant, which I'll quickly show you how to do as well. So for the 2x2 variant, you duplicate the entire design, but at the other side. So you do this, you put these 2 pistons here, and then you put some blocks here, like this. Then you gotta duplicate this entire circuit on both sides. So I think we're going to run into some bud powering issue, but we'll see. So I'll just rebuild this entire thing, and put this here, 2 ticks like so. Then you're going to have to run a circuit off from the side, such as a NOT gate, and then this. Just check this works. Yep, that's fine. and then this can be powered off to the side. And I'll bring it down here, and hopefully this doesn't bud power anything. And just flick this lever, and off, and there! The 2x2 Jebidor. And yeah, perfect! So this is how you can have a hidden base within a wall without any indicator that you have a base here. So this is one of the more common piston doors you find in Minecraft. You can build more complex piston doors, in fact really complex piston doors, but this is all the basics to pistons doors that I'm going to need to show. So you can see why we need NOT gates, and you can see why powering pistons is quite a bit trickier than powering all redstone components. Anyway, this is going to be the end of this tutorial of redstoning. I hope you enjoyed it. If you did enjoy it, please leave a like. If you'd like to see some more from me, please subscribe, and I'll see you later.